Hey everybody, we're going to start with the last two problems on the 2017 Mcas. So if you're trying this, there's the PDF in the description, and the idea behind this is that you try this on your own first, and you watch the videos to show you how to go ahead and complete these. So let's get right to it. And this is also the calculator section, so you can use the calculator for this. You're also going to want to use the reference guide with the formula sheets for this problem. Okay, so here we go. We got three objects are shown below: a sphere, a right circular cylinder, and a right circular cone, as we see here. Part A is saying, what is the volume in cubic inches of the sphere? Show or explain how you got your answer. Okay. So we're going to calculate the volume of a sphere, and we're told the radius is 10 inches. So this is a key piece of information right here. Okay. So part A, I'm going to use a different piece of paper here. So we're going to need to know the volume of the sphere. So let's find out what the volume of the sphere formula is. So volume formula is right here. You go to sphere, and it's 4/3 pi r cubed. And 10 inches. Let's not forget our unit of measurement. So the r is 10 inches. So V equals 4/3 pi 10 to the third power. So we're just going to, this is just order of operations here, so we're going to use exponents first. So 10 cubed is going to be 1,000. So 4/3 times pi times 1,000. So let's do 4 times 1,000 over 3. So 4 times 1,000 divided by 3. Okay, so there you go right there. So it's going to be 1,333 inches, 0.3 repeating, times pi. And that's the volume. And it's inches cubed, because it's the volume, so it's cubic inches. Okay, and that's it. Part B. They say the height of the cylinder is 2 times its radius. And this is actually the radius of all the objects at 10, so they all have the same r, so that makes it easier. What is the volume of the cylinder? So we need the cylinder volume, so that's going to be, it's a right circular cylinder, so right here. So pi r squared h. So V equals pi r squared h. So we know the h is 2 times the radius, so 2 times the radius would be 20. So h is going to be 20. R is 10. It's inches. So V equals pi 10 squared times 20. Okay, so we're going to do the exponent first. So 10 squared is going to be 100. So V equals pi times 100 times 20. And 100 times 20 is going to be 2,000. So 2,000 pi. Volume equals 2,000 pi cubic inches. There we go. Alright, so the first two parts really not that bad. Just can you use a formula? Can you plug things in? Okay. Part C. The volume of the cone is equal to the volume of the cylinder. Okay. We already know what the volume of the cylinder is. What is the value of K? The height in inches of the cone. Okay, so let's see the volume of a cone formula here. Right here. So V equals 1/3 pi r squared h. So it's really just the same thing as the cylinder, just 1/3 of it. Okay, so let's write that down. So C equals V equals 1/3 pi r squared h. And we're told that they have the same volume as of that of the cylinder. Okay. And in this case, they're solving for K, which is going to be the h. Okay, so we're going to say it's, how much was it again? 2,000 pi. So 2,000 pi. And I'm not putting any cubic inches. We'll save that for the end. This is less to write. 1/3 pi, and the r is 10. It's 10 squared. And again, we're going to change it to k. It doesn't really matter, but we're going to call it k. We're solving for, I'm assuming we're solving for k. Yep, we're solving for k. Okay, so instead of evaluating why is this losing focus? All right. locked or not? I thought I locked it earlier. Never mind. Okay, so instead of evaluating an expression, we're going to solve an equation here. We're solving for k. So let's go ahead and simplify this a little bit. So we have 2,000 pi equals 1/3 pi. It's going to be 100 times k. So let's get rid of this 1/3. We're going to multiply. Actually, let's get rid of the pi's first. So we're going to divide both sides by pi. The pi's will disappear. So we're going to have 2,000 equals 1/3 times 100k. To get rid of this 1/3, we're going to multiply by 3. So this will become 6,000. This goes away, so now we have 100k. We're going to divide by 100 because that's our coefficient. That's 2 zeros. So k would equal 60 inches. And that's it. Okay. That's not bad. Part D. The radius of the sphere will be changed so that the volume of the sphere will be equal to that of the volume of the cylinder. Okay. By how many inches would the radius of the sphere have to change for its volume to be equal to the volume of the cylinder? Okay, so let's go ahead and write the volume of a sphere formula first again. The volume of the sphere formula is right here, 4/3 pi r cubed. So V equals 4/3 pi r cubed. Okay. And the volume of the cylinder. Okay, the volume of the cylinder was 2,000 pi. So 2,000 pi. Now, what would r have to be for this to be the case? We're going to solve for r and then compare this r to the old r. That's what we're going to do here. Okay. So it's actually very similar to the previous problem with an added step, but a lot of people would read that and not understand how to find the difference between the two r's. We're just going to solve for r in order to fulfill this requirement. Once we do that, we can just, it's a simple matter of subtraction. So let's solve for r. So we're going to get rid of the pi's. We're going to write 2,000 equals 4/3 r cubed. So we have a fraction as our coefficients. We're going to multiply by its reciprocal. So we're going to multiply both sides by 3/4. Okay, so 3/4 times 2,000 would be 6,000 over 4. It's r cubed. We can simplify that. 6,000 divided by 4 is going to be 1,500. Okay. So 1,500 r cubed. Now, I don't think that's a cubic root, but I guess we'll find out. So we need to find out what this r is. Now, the original r of the sphere was 10. So we just see how far away. Well, first we're going to get r. We have r cubed here, so let's go ahead and do the cubic root of both sides. This is where some people would get confused, I think. So r is the cubic root of 1,500. Now, can we simplify that? Let's find out. So that's going to be 100 times 15. And 100 is 10. Just making our factor tree here. 2 and 5, 2 and 5. This is 3 and 5. Okay, so we're going to circle all our prime factors. So we have 3 5s, 2 2s, and a 3. Okay, so we have root of 2 times 2 times 3 times 5 times 5 times 5. Now, we're looking for numbers that happen 3 times because it's a cubic root and not a square root. So there's 3 5s here. Okay. So that's going to go on the outside. So we have 5 cubic root of 2 times 2 is 4, 4 times 3 is 12. So that is the volume of R. That's what it would have to be. So we want to know how much it would change by. So, so what we're going to do is look at the the original, which was 10. All right. This is a weird problem. Okay, so maybe I'm doing this wrong, but I don't think I am. How much would I have to change by? By how many inches? Okay, so we're going to get a very odd number, unless I screwed this up somehow, but I don't see how I did. Let me go back and just double check this real quick. So we divide by pi, we multiply by the reciprocal, and then we got 6,000 divided by 4,100. Yeah, cube root. Yeah, this is all. This is correct. Okay, unless I'm missing it, but I don't think I am. So this is very interesting to me. Let's see here. 1 second. Okay, so now there's two ways you can go about this problem. If you have, and I'm not sure how this Mcas, how they wanted it, because they're not specific. If they want it in terms of, if they want a rounded decimal, if they want it in terms of rational numbers. So, because you can convert this to a decimal, and it's an estimation, obviously, because it's an irrational number. It's going to be about 11.5, roughly. So there's two ways of writing this. You could, this is what I would do, because this would be the most accurate way. You do the absolute value of 10 minus 5 cubic root 12. That's the most accurate way of writing it, because it's going to show you the difference between the two. This would be inches. Or, if you estimate it to be a decimal, which is about here, you would say, you'd round it. Let's say you'd say 11.45 minus 10, and it's going to be about 1.45 difference estimation. So if I was going back in time and I was taking this 5 years ago, well, I'd want some clarification by DESI of how they want this, but either one of these is argued. This is the most accurate. This is another answer I think that would probably be appropriate. So this problem, this section of the problem isn't hard because of what it's asking you. It's hard because a lot of people are going to struggle with cubic roots. And then this, I think a lot of people would struggle writing this. But first three sections, I think most people will be able to do no problem. Okay, let's check the last one. Oh, that's wrong side. There we go. Okay. That was the last one. Alan wants to add to his existing collection of 300 bottles. Starting today, he'll collect 25 bottles each week. What is the total number of bottles in Alan's collection after 4 weeks? Sorry, so this is a linear equation problem here, linear function. So it starts with 300. So starting value is 300. And the rate of change is how much? 25? Yeah. Rate of change. It's going up by 25 per week. So after 4 weeks, what happens? So, well, 4 weeks go by, and there's a few different ways. I would want to write a function, but for this problem, we're just going to do that. So we're going to do 25 times 4. That's 100. Add that to the starting value, and it'll be 400 bottles. Okay, so that's without writing as a linear expression. All right, write an expression. Here we go. To represent the total number of bottles in Alan's collection after W weeks. Okay, so we're going to have the starting value, which is 300. Actually, let's write it out before. Let's do the starting value plus the rate of change times the number of weeks. Because it's changing every week, right? So there's three things here. What it starts at, how much is changing each week, and how many weeks go by. So the starting value is 300 bottles. The rate of change is 25. And the number of weeks is represented by the variable W. So that's it. Okay? And that's how these problems usually work. Usually it's asking you to create an expression to represent a linear relationship. And that's not different. That's on the current Mcas. They do that a lot. Although it's typically not a 4-part problem. It's usually a 2 or 3-part problem. And usually sometimes they skip this first part. They go right to the expression. After how many weeks will Alan have exactly 1,000 bottles in his collection? Okay, so we're going to use this and set that equal to 1,000 and solve for W. So 300 plus 25W equals 1,000. And we're just going to solve for W here. Okay, so let's subtract our constant from both sides. Oops, I forgot a 0. There we go. So 25W equals 700. Then we're going to divide by our coefficient, which is 25. W equals, and then we're going to have 700. See that? There you go. Divide by 25. 28. So 28 weeks go by. Okay. Alright, Alan's goal is to have between 1,500 and 1,600 bottles in his collection. Write and solve a compound inequality to determine the number of weeks it'll take Alan to reach his goal. Okay. Alright, so here's our expression, 25W plus 300. So it has to be between. It doesn't say equal to, it's between. So it's greater than 1,500 and less than 1,600. That's an and statement. So we're going to go ahead and split that and rewrite it. So 1,500 is less than 25W plus 300. And 25W plus 300 is less than 1,600. We're going to go ahead and solve this. Alright, so minus 300. So 1,500 minus 300 would be 1,200. This is less than 25W. Divide by our coefficient. Oop, might have been 24. That's weird. 1,200 divided by 25. It's 48. Okay, so 48 weeks. And let's see here. So subtract 300. So 25W is less than 1,300. Divide by 25. That should be 52. Let's just double check that. Yeah, 52. Okay. I screwed that up. Over here should be 48. So W is greater than 48. I don't know why I wrote it like that. And here W is less than 52. So it's between 48 and 52 weeks. Determine the number of weeks. Yeah, so it's between 48 and 52 weeks. Or you could write it like this, 48. So I guess it'd be 49, 50, and 51. Yeah, there we go. That's it. All right, so hopefully that was helpful. I think that first one was definitely more challenging, just because of that last part. But this one shouldn't be too bad. All right, guys, so hopefully that was helpful. Let me know if you have any questions. Thanks for watching.